Hello. Okay, we are on our last problem. Hooray! So problem 6. Oh, I don't have the doc open. Let me read the prompt. The prompt is very important, and I'm gonna try to do this new format of how to break down a question. Instead of just going through the answer, I want to get into the habit of breaking down the prompt into more basic, like what do we need, what are we asking for, what is the goal, um, and write it in like a bullet point or something, a couple of bullet points or something. So next time when I am in an interview, my brain would just be able to do that naturally um, and faster. So I'm gonna try a slightly different format just to try out. I'm not gonna say it's gonna be good or any clear on the whiteboard, but I'll try. So, but it's how I could. It's not problem solving. It's identifying how what the problem needs and what it's asking for. I think doing this, because when I read this, I was like, what? Number 6, I was like, what is it? What is it? I don't even know what's going on. And then I had to really break it down, like just using like basic sentences of all the requirements and the things that we would need to know in order to perform this, code correctly. So yeah. Number 6 is asking. So given an input stream of n characters, so let's write this as stream non. So the like sister problem to this was, here's a string, find the letter that does not repeat. But the important thing here that we should know is stream here means that we don't have all the inputs in front of us, and that it's slowly being trickled in, or however computer stream. Um, and that's really important, because that's going to impact how we solve the problem. Otherwise, if it was a sister problem, I think we just like, well, my first thought was, well, just make a dict and then check the dict for a quick lookup and then increment whatever, if there's is in it, and if there isn't, then we found it. But this is a stream, so we can't put something that we don't have already in a dict, because this is coming in real time, and that is the significance I wanted to highlight of this. Um, so yeah, and actually, did I finish even reading the problem? No, I didn't. It's a long problem. So, given an input stream of n characters consisting only of small case alphabets. Okay, so what we know about the problem is that it's a stream. So I'm going to write in bullet points. There's a stream. Hopefully I break it down. This would be a better way to, kind of refer back to the code and see what I'm doing later on. So it's a stream, not a string, stream. And thankfully it only has small case, so it's a lowercase alphabet. Is that what it says? Alphabets, yeah. Okay, so lowercase with, wait, how many letters? 26 letters in the alphabet. A lowercase 26 letters. Excuse my bad writing. I don't know why there was a pause. I'm sorry. I didn't even finish reading the question. So, given an input stream of n characters, so we don't know. So it's a stream of n. So we don't know how many characters are coming in, but we know that it's only lowercase 26 alphabets. We want to find the first non-repeating character each time a character is inserted into the stream. And if there's no non-repeating characters found, just print -1. So basically, we want to find the first first, I think first, not, we don't want all of them, just the first non-unique character. First non-unique um, character. Terrible, terrible, not so nice writing. Um, each time it enters in the stream. You know what they should invent? They should invent a freaking like you write it and it will like kind of intuitively it'll show you a nice neater version that's not your handwriting, but it will show you the word that you're trying to write. There must be some app that does that. Like we need that. It all looks so bad on this. So that's an idea. Anyways, what was I doing? Oh yeah, if there is if everything repeats, then return -1. If no unique, return -1. So I hated word problems in school in math class, but like pretty much algorithms is a lot, but basically like word problems where you have to break down what exactly the word problem is, what it's looking for, and then use math to solve it. And I think I'm not the only one. A lot of people hated word problems, but um, yeah, um, but it's doable. So the language is like kind of weird. So what we're trying to do is find a list of n characters, lowercase. We're going to find the first newly unique character each time it enters the stream. And if none is found, then return 1. And so I think I made that pretty clear. Let's see. Oh yeah, the example. The example given is in the stream, so I'm just gonna. So this is the stream. Um, blah, blah, blah. Stream. A B C. Is that it? Yes. Okay. So A will first go into the stream. Will first enter the stream. Actually, that's quite a confusing way to write it then, because it looks like everything's here, but it's not. So I don't have any of these right now. But A goes into the stream, and A, because being the only character in there, is unique at first. So it was unique, and then another A comes and joins and buddies up with this guy, and they're like, hey, we're the same, so we're not unique anymore. So then we return. So here would be -1. Here would be A, and then B joins the party and was like, oh, I'm unique, cool. And then B would be B because it's a unique thing. And then C would join the party, but B is already unique. So who cares what C is? So C is still B. Does that make sense? Cool. Yes, I think I did that okay. um, hmm. I'm gonna pause a lot because I'm still kind of thinking about the solution. There were two. So my first instinct was still gonna be dick or hash is what it's called. Um, I am pretty sure we're gonna need a hash table in this because what we're trying to look for. So the problem needs. Okay. Oh yeah, that's right. I'm gonna need to write in green what the problem basically needs in order to build to build a solution. So what we know about the problem is the input coming in and that and it's a lowercase and God, I'm still thinking. And what we need when we're trying to our goal is to find the first non-unique, so we're trying to find the first unique. I think non-unique is terrible. Okay, I'm gonna I swear I hate word problems. I'm gonna write unique. We're just gonna find the first unique character. That's right. I'm just gonna do this. Because non-unique if is just no. We don't need that. Just say unique. I'm gonna find the first wait, is this oh non-repeating. Duh. We're gonna find yeah, but that's first unique. Sorry, not non-unique, non-repeating. Ha! I caught myself. Cool. Good. I fixed it before because I was like, what's going on? Yeah, I'm not recording these all at once, so give me a second. Let me just gather myself here. What was I talking about? Oh yeah, we need to find what the problem needs to solve it. So what we need to know, things that we need to know in order to solve the problem, and things that we need to keep on track is the order of the stream. So we need to um keep yeah, we need to keep order that it came in, because that's how we'll know if something's unique or not as it comes in, because it's a stream. So we need to keep a good order of the data, and we need to be able to look up what is already in data without having to iterate through again everything. So quick lookup, and I think that's it. Oh, duh. Obviously, we need to keep, besides the order, we need to make sure we know if it's the actual character is has been repeated before or not. Period. Like the moment it's been repeated, we don't need it. So that's important. So true, false, character repeated or not. Oh my god, my pen. Okay, this is gonna be annoying. It's gonna be annoying because I don't know what happened. I'm just gonna write slow. True, false. If the character if the character has repeated itself. Repeat. Okay. So yeah, yeah. So yeah, my first reaction was we're gonna use the dict, use hash for this because we need to map out these values and look them up fairly quickly. So for this problem right here, I'm like hash and keep in order. This problem is well, it could be a bunch of things. We could do linked list, a doubly linked list because we need to be able to remove doubly linked list, or a queue. And true or false, if the character repeats, we could just use a simple array and then put the value in there. No, which must no. Well, yeah, I guess so. Hash again, or just an array. I think you have to transverse the array. So never mind, still hash. Duh. Ha 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 ha. Sorry. Never mind. Yeah, I'm trying to think it through. Oh goodness. So yeah, there's probably some other data structure, but I have not learned about graphs yet, or binary trees yet, or trees, period. So I'm gonna just land on what I know safely. And unfortunately, my notes end here, so I am going to. I think my notes ended here because I was like, oh, I got it. Yeah, okay, I understand. So There's two main ways of doing it. One is method one. I forgot how to spell method. Method. Ugh, it's so bad my writing. This is gonna be a long video. Method one. So is going to be a doubly linked list. With two hash lookups. So not exactly space efficient at all, but it will be the hashes will be done will need to work in constant time, which is great, and the Willy linked list will be O of n. So that is the method for if you were to use a linked list to um, keep order. So a linked list to keep in order, a doubly linked list to keep order. Oh my goodness. And this is our data in here. A, C. Yeah. And then a hash so hash one, I think, will we need look up, yeah, but what am I looking up? What am I storing? Okay, let's just go to, so the first hash is gonna go, hey, was this repeated? True, false hash. And then we're gonna be like, here's the corresponding 26. So 126. And then we're gonna be like true, true, false. Wait. We're gonna initialize everything to false until one becomes repeated. Then it's true, and then we're gonna look at what's left of the false, and then we're gonna get our answer. But yes, and then the second hash is going to be the position, because so I'm just gonna right here is the hash position, so we could look it up quicker when we get it from a linked list. So oh wait, what am I doing? I'm drawing the wrong thing. Hash position would be stored as like so this one's gonna tell us exactly where, if a quick lookup of exactly if whatever came from the linked list, the stream, happened or not, and it's going to be much quicker than having to transverse um, the linked list for the thing again to toggle on this. So that's why we use two hashes in a linked list. Hopefully that makes sense. So like the thing comes in here, A comes in, and A has never occurred before, so A is false and A is currently unique. And then we put in A, and A is at position 1 because this goes to position 1 to 26 as well. I can write 26? What? What's wrong? Right there. Okay. Wow, this is much harder. Writing on the tab is much harder than I thought. And then the next time A comes in, I was like, whoa. And then this flips. Next time comes in, and it looks, it goes here first, sorry. It looks up here and goes, hey, I am a quick look up, I'm at position 1. And let's go here and go, hey, I am not unique. So I'm going to change that and flip it to true. Oops, where's the eraser? I'm going to flip it to true because I'm already in here, you know? And then all these B will eventually become true too, right? Oh, no, the B doesn't. The B doesn't, once the stream ends, or the stream is empty, like everything's done, then actually not sure how that would work. But then it would be the B would return. Oh yeah, so once everything is in, the moment we find the non-repeating, which I don't know how there's a moment because there's a stream of data coming in, and how will we know B is currently, whatever. Um, then we go, oh, this is the one that's false, which means that is the unique character. B is so at position 2, and then we're just gonna return B. So yeah, that's method 1, and I don't like it because that's what I try to get at first. I try to find what I tried to understand at first, and I was like, I don't know if I think this is as it's like because we're like going here and then here and then here, and I'm just like, I feel like that's more complicated than necessary. So obviously I didn't think of this next solution, but or nor this one, but I thought this one, the second one, method 2, using a cube